Dear learners, in continuation with the lecture of the past, I am going to talk about the different basic concepts which are associated with the calculating the differences between the two means. And here we are going to discuss about the different types of the errors in the testing. As you will recall from your statistics text, the purpose of the t-test and the analysis of variance is to test the hypothesis. With different types of analysis, there is always the possibility of reaching the wrong conclusion, and there are the different types of the error we can make while making the conclusion. It can be of the two types. The first one is called the type 1 error and another is called type 2 error. The type 1 error, also known as we can say the error of rejecting a null hypothesis when it is actually true. In other words, there is an error of accepting an alternative hypothesis, the real hypothesis of interest, when the results can be attributed to the chance. It means that in reality there exists no difference between the two means, and if there is a difference, it may be because of the chance or because of some accidental factor. In that case, the type 1 error occurs. Okay, plainly speaking, it occurs when we are observing the difference when in truth there is none. More specifically, no statistically significant difference. This occurs when we think that there is a difference between our groups, but in reality there is no difference. We can minimize this possibility by selecting an appropriate alpha level. Okay, in statistics, basically we go for the level of significance of 0.05 and 0.01, and with the help of deciding the level of significance, we can minimize the type 1 error. The type 2 error. The type 2 error is also known as the false negative, the error of not rejecting a null hypothesis when the alternative hypothesis is the true statement of nature. It means that where in this case, the type 2 error, we are rejecting the alternate hypothesis while there is a true difference lies between the means of the two sample. It means that there is error of rejecting the alternate hypothesis and accepting the null hypothesis while there is a true difference. Okay, plainly speaking, it occurs when we are unable to observe a difference when the truth there is one. Unfortunately, these two errors are inversely related. As we try to control one type of the error, we actually increase the likelihood that will commit a type 2 error. It means we should try to understand the different type of the probabilities of accepting and rejecting the type 1 error and the type 2 error, and we should try to raise the level of the significance in the statistics. With the help of that, we will have the control over minimizing the type 1 error and type 2 error. Another very fundamental concept which has been associated while determining the difference between the means of the two samples is the power of the test. Power of the test means whatever value of the t or f or different types of the r, z we are getting, what is the actual strength or the power of those values. And with the help of the different types of the tests, we can come at a level where we are in a position to talk about the actual strength of the relationship between the variable among the variable. Ideally, we would like to test that we use to correctly identify whether in fact there is a difference between the between our groups. Okay, that is called the power of the test. Okay, tests vary in terms of their power. For example, the parametric tests are having their own strengths. For example, the parametric tests are having different assumptions related to the sample size, related to the distribution of scores within the normal probability curve, about the different type of the levels of the measurement. For example, the normal probability curve, it takes the parametric statistics takes into consideration the ratio and the interval scales, while in the case of the non-parametric test or the statistics, they take into consideration the ordinal and the nominal scales as well. And the non-parametric statistics is not associated with the normal distribution of the data, and basically they take into account the scores into the ordinal or in the nominal form. It means that if we are having any result which we are getting with the help of the parametric tests, they will be more robust, they will be having the more power and more strength in comparison to the results which we are getting from the non-parametric type of the tests. It means if we are having the large number of the sample size and the data is qualifying for all the assumptions of the normal probability curve, in that case whatever result we get from that type of the data, we are going to make the generalization about the entire population in a better manner in comparison to a data which is not actually representing or which is not fulfilling the assumptions of the normality of the distribution and the other type of the scales related issues. We are not in a position to normally make generalization about the population based on the result of with that type of the statistics. Apart from all these distribution related issues, type of the scale issues, and we can say the type of the normalcy of the data, there are other characteristics or the other attributes which are also responsible for determining the power of the test. First one is the sample size. Sample size is very important because the degree of freedom is associated with that, the homogeneity of the scores are associated with that, and if we increase the sample size to a certain level, we can minimize, I will say not eliminate, but we are in a position to minimize the sampling error, and after that we are not statistically in a position to minimize the sample error, because the sampling error will remain in the study or remain in the research, okay, to the certain extent. But while increasing the sample size of, up to the level of the 400 or above 370, we are in a position to minimize the sampling error. The another issue is the effect size. Effect size is the strength of difference between the group or the influence of the independent variable, and effect size is calculated with the different scores like different formulas like eta square and Cohen's d, and I will be discussing all these in the coming slides. And the another issue is the alpha level set by the researcher. Okay, if we are having the alpha level of the 0.01, in that case we will have the probability of the 99% that we will get the true result if we are raising our level of significance to 0.05. In that case we are having the probability of getting the 95% of the true score, and still we will have the remaining chance of the 5% of getting our result because of the error. The power of test is very much dependent on the size of the sample used in the study. According to Stevens, when the sample size is large, for example 100 or more subjects, then the power is not an issue. However, if you have a study with the group size, when the group size is small like n is equal to 20, then you need to be aware of the possibility of the non-significant result may be due to the insufficient power. Stevens suggests that when the small group sizes are involved, it may be necessary to adjust the alpha level to compensate. For example, you can set the cutoff of the 0.10 or 0.15 rather than the traditional 0.05. The power analysis gives an indication of how much confidence you should have in results when you fail to reject the null hypothesis. The higher the power, the more confident you can be that there is no real difference between the group. It means कि if we are having the high Cohen's d or eta squared value, we are very much confident about the outcome of our results. One way that you can assess the importance of your finding is to calculate the effect size or the strength of association. This is a set of statistics which indicates the relative magnitude of difference between the means. It means कि if we are getting the difference, and what is the amount of the strength is associated with that difference. In other words, it describes the amount of the total variance in the dependent variable that is forecasted or predictable from the knowledge of the levels of the independent variables. And there are a number of different effect size statistics, the most common which are the eta squared value, Cohen's d and Cohen's f values, which are computed for determining the effect size of the tests values we get of the t or the ANOVA. Okay, how we can calculate the effect size of the independent sample t-test? Here the eta squared is equal to the t square upon t square plus n1 plus n2 minus 2. Replacing the appropriate values with the example above, the eta squared is equal to 1.62 square upon 1.62 square plus 184 plus 252 minus 2, and here we get the eta squared value of the 0.006. And the different guidelines has been proposed by the Cohen about what is the meaning of the values of the eta squared we get from the studies. And if we get the value of the 0.01, it basically reflects the small effect, and if we get the value of the 0.06, it reflects the moderate effect, and if we get the eta squared value of the 0.14 or the above, it is going to reflect the large effect size. And for our current example, you can see that the effect size is 0.006, that is very small. We are having different formula for calculating the effect size for the matched sample or the paired sample t-test. Here all the things are same, but the values of the n is a bit modified. Here the eta squared is equal to t square upon t square plus n minus 1. In place of the n1 plus n2 in the case of the independent sample t-test, here in the case of the paired sample t-test, the n1 plus n2 is replaced by the n, and here the interpretation part is again the same. And it means कि for the small effect size, the value of the eta squared is 0.01, 0.06 is equal to moderate effect, and 0.14 is equal to large effect. Okay, in this slide basically I will be talking about a bit of the statistical part which is associated with how we can actually go for the computation of the differences between the means of the two samples. and I have tried to organize the lecture, okay, based on the different types of the t-tests used for calculating the mean difference with the different types of the sample attributes or the characteristics associated with the sample. And at the first place, I will be discussing about the independent sample t-test, or the calculating the t-test for the samples which are independent or uncorrelated. What does it mean? The independent sample t-test is used for testing the differences between the means of the two independent groups. Okay, independent groups means they are basically independent of each other and they are not related. It is particularly useful when the research question requires the comparison of variables. Variables means basically they must be measured at least at the ordinal level obtained from the two independent samples. For example, do males and females differ in performance on a standardized achievement test? What is the effect of the drug versus no drugs on rats' maze learning behavior? It means कि here we want to compare the two independent samples with respect to one variable. And if we go for any type of the independent sample t-test, there are certain requirements. Requirement means कि until unless कि our data is not qualifying all those assumptions or requirements, we cannot go for the independent sample t-test. The first requirement is only one independent variable. Independent variable should be the categorical variable. It should have more than one levels. For example, the gender of the subject, the socio-economic status, the economic status, okay, and it should have the two levels of the independent variable, especially for the t-test. If we are having more than two levels of the independent variable, for that we will have to go for the one-way analysis of the variance, and we should have one dependent variable. Dependent variable means it should be a type of the continuous variable on which we try to see the effect of the independent variable. The assumptions: the sampling distribution of differences between means is normally distributed. Because the independent sample t-test belongs to the category of the parametric statistics, it should fulfill all the assumptions of the parametric statistics, like the data should be normally distributed, the sample size should be large, and all the scales should be either in the interval or in the ratio form, and the score should be internally homogeneous. Homogeneous means कि if we are drawing a sample from a population, the scores of the sample, it should be internally homogeneous, or it should be alike, or they should have the component of the sameness. Now I will be talking about how we can statistically calculate the independent sample t-test, and for this we should have the values of the mean for the two samples and the standard deviation for the two samples, and we put that value into the formula. And basically t-test, the general formula for the t-test is equal to T is equal to D upon SEMD or SED, and D basically talk about the mean difference M1 minus M2, and SED or SEMD it talks about the standard error of the difference or the standard error of the mean difference. Okay, here the formula is basically कि okay, first we are going to have the value of the x. The x is basically the deviation of score of the first sample from its means. It means कि with the help of the x minus m1 we can have the value of the small x1, and with the help of the x1 x2 minus m2 we can have the value of the x2, and the standard deviation is equal to the summation x1 square plus summation x2 square upon n1 minus 1 plus n2 minus 1. And the step 3 is the computation of the standard error of the difference between two means by using the formula. The standard of error of the difference is equal to SD upon under root 1 upon n1 plus 1 upon n2. So with the help of this formula we can calculate the independent sample t-test, okay, between the two means. The step 4 is equal to compute the t value for the difference in the two independent sample. The following formula is used to determine the t value. Is the t is equal to m1 minus m2, okay, minus 0 upon standard error of difference, okay. And the step 5 is the degree of freedom. The df is calculated with the following formula. Df is equal to n1 minus n2 plus n2 minus 1. Okay, with the help of the formula we can calculate the value of the t-test for the independent sample. Okay, here is the example. Scores of the boys and girls and the t-value calculation. An interest test was administered to the 6 boys and 10 girls. They obtained the following score. Is the mean difference between the two groups they are significant? Here are the scores obtained by the boys, okay, that is the capital X, that is the 28, 35, 32, 24, 36, and the value here is the scores obtained by the girls are the 20, 16, 25, 34, 20, 28, 31, okay, 24, 27, 15. Okay, here with the help of this table we can have the value of the small x and x square. The small x is basically the x minus m, and the x square is the square of the small x. And okay, same is with the scores obtained by the girls. Here we have the value of the small y and the y square. Okay, we can put all those values into the formula, and okay, at the first place we can calculate the mean score for the boys, that is 180 by 6 is equal to 31.66, and the mean score for the girls, that is 240 by 10 is equal to 24. And the standard deviation, okay, again we can compute with the help of this formula, is under root summation x square plus summation y square upon n1 minus 1 plus n2 minus 1. And okay, with the help of this formula we got the value of the 5.74. Now we have to compute the standard error of the difference, and the standard error of the difference is equal to SD into under root n1 minus n1 plus n2 upon n1 n2, and with the help of this we got the value of the standard error of the difference. Okay, the value here is the 2.98, and after putting the value of the m1 minus m2 upon SED we got the value of the 2.58, that is the value of the t, and the degree of freedom here is the 14. Okay, with the help of this we can have the interpretation part. Referring to the critical values in the table for the t-test that are given in the appendix of the textbook on the statistics for degree of freedom, we get the 2.58 at the 0.05 level and 2.58 at the level of 0.01. Okay, since our t is less than 2.14, therefore we can say that the mean difference between the boys and the girls is non-significant. What does it mean? It means that the scores of the boys and girls on the interest test they are alike and there lies no significant difference between the interests of the boys and girls, and if there is any difference it is because of the external factor, or the we can say the factor which are beyond the control, and it may be the because of the some accidental reason or some other factors, and statistically it is not true. It means that with the help of the independent sample t-test we can have a value of the t which is able to detect the true difference between the means of the two samples which have been drawn independently from the population, and they are unrelated, and whatever value we get from the t-test, it is basically going to talk about the true differences between the means of the two samples with respect to the attribute or the behavior or the psychological characteristics of the individual belonging to two independent samples. And since this independent sample t-test belongs to the category of the parametric test, and if we are having the sample characteristics which are not normally distributed, in that case we can go for the non-parametric equivalent of the independent sample t-test. Basically that test is called the median test, and basically when we are not having the normally distributed data, in that case we can go for the non-parametric equivalent of the independent sample t-test, and we can have the same type of the result, but the non-parametric tests are having certain limitations with respect to the generalization of the results, and with that limitation even we can have the certain type of the results which may be we can say which may be useful for the result, useful for the study, and sometimes useful for the researches. And if we are having the possibility to get the sample which is having all the assumptions of the normal distribution curve, and if it is qualifying the parametric tests, in that case we should definitely go for the parametric type of the statistics. Dear learners, now I would like to conclude the lecture. In this lecture I have talked about the certain basic concepts related with the differences between the means of the two sample. The one is the errors in the measurement, in which I have talked about the type 1 error and type 2 error, and what are the conditions in which these type of the errors may occur. Another basic concept which I have discussed is the power of the test, and the power of the test is basically talks about the strength or the magnitude of the association, and with the help of the eta squared, with the help of the coherence D, with the help of the coherence F, we can calculate the power of the test and the strength of the test. And I have also talked about the independent sample t-test and what are the assumptions and conditions for the use of the independent sample t-test, and I have also talked about the numerical example of the independent sample t-test. Normally the independent sample t-test is a parametric technique for detecting the differences between the means of the two samples, and if we are having the large sample and independent sample and we are interested in detecting the differences between the two means, in that case we can go for the independent sample t-test, and whatever value we get from the independent sample t-test, basically it gives you an idea about the differences between the means of the two sample with respect to certain psychological behavior, attributes or the characteristics. Thank you very much.